Let's look at number 32F here. We're going to use the fundamental theorem of calculus part 1, right? Which says if I'm integrating some function, little f, going from a lower limit of a to an upper limit of b rather. And of course, f of t is just our dummy variable, if you will. This dt is just telling us that the variable of integration is t. Then the fundamental theorem of calculus says that this is another function, capital F of t, and we say evaluate it at the upper limit. So this notation here means what? Capital F of b minus capital F of a. And capital F, remember, is the antiderivative. So the derivative of capital F is little f. So that's the relationship. So that's the fundamental theorem. That's the amazing thing, that we're able to evaluate this definite integral by simply evaluating the antiderivative at these endpoints and subtracting in that order. So that's what we're going to do here. My first step on this one is to be able to easily find the antiderivative, is to rewrite using this fact that we know about negative exponents. And so in other words, 5 divided by t to the fourth is 5 times what? 1 over t to the fourth, or t to the negative 4. And then minus what? 8 times what? T to the negative 3. So now we can make use of the power rule, right? Which says the antiderivative of x to the n is what? X to the n plus 1 divided by n plus 1. Of course, plus a constant in general, but notice when we're doing definite integrals, we don't ever include the constant of integration, because if I have the constant of integration here minus the constant of integration here, then see that constant minus that constant is 0. So we don't have any constant of integration when we're looking at the definite integral. Indefinite integral, right, with no limits of integration, just what is the antiderivative? Yes, you include that, it's plus c. Do not include the plus c with the fundamental theorem of calculus, though, part 1. So what's the antiderivative of 5t to the negative fourth? Well, 5 is a constant multiple, and t to the negative 4 by this rule is t to the negative 3 divided by negative 3. So note here, be careful. Sometimes people have trouble adding sign numbers and things. Negative 4 plus 1 is indeed negative 3. And then negative 8, the antiderivative of t to the negative 3 is t to the add 1 to negative 3, negative 2 divided by negative 2. So there it is. And notice I don't have the integral symbol anymore. We use the evaluation bar. This means evaluate this expression at the upper limit of negative 1, and then minus the lower limit evaluation. Now, before I do that, I'd like to clean this up a little bit. So notice this negative sign here, 5 times negative 1/3 is going to be negative 5/3, and this t to the negative 3 I'm going to bring back down as what? T to the positive 3. So making use of this, again, property here just to bring it back down into the denominator. Just makes it easier to now evaluate it. So I bring it to, rewrite this as a negative exponent in order to find the antiderivative, and then write it back to the original without the negative exponent. Same thing here, be careful, it's minus 8 divided by negative 2, so negative divided by negative is positive, 8 divided by 2 is 4, and t to the negative 2 power becomes 1 over t squared. So here's my antiderivative, and I'm going to evaluate it at negative 1, and so I'm going to replace t with negative 1, all right, and then evaluate it at negative 2 here and here. Okay, so be careful that this negative sign doesn't come outside, doesn't get distributed through it. It's just, this negative sign is just on this fraction plus this one. Now this minus sign does get distributed through, but I would just go ahead and evaluate. Notice negative 1 cubed is negative 1, negative 1 squared is positive 1, negative 2 cubed is negative 8, negative 2 squared is positive 4, and then I can simplify. So I get here, negative divided by negative is positive, 5 divided by 3 is 5/3. This is 4 divided by 1 is 4. This is 5, and this is, notice the negative here, and divided by negative, so negative divided by negative is positive. 5, 3 times 8, 24, positive 5/24. 4 divided by 4, positive 1. right? So, and there's various ways you can evaluate this. I mean, at this stage, you can even use your calculator and use the convert to fraction key, but it's not too bad. If I distribute this negative sign here, -5/24 -1. Now, some of you like to evaluate this and then do the subtraction last. You can, but I'm going to go ahead and distribute this through. And here I just noticed that 4 minus 1 is 3. I got my +5/3. I got my -5/24. Just simplify that way. Now I can just combine as one fraction by finding the common denominator, which I've got this is really 3/1. And so I've got denominators of 1, 3, and 24. 24 is the least common denominator because 3 divides evenly into 24 8 times. And so I can write these as all equivalent fractions over 24. Now I can simply do 72 plus 40 minus 5, and I get 107. So there's my final result. Again, it's good to review. You should be able to deal with fractions. They should be your friend, but you do have technology, so you can use to check your answer. Ways to do that, right? Even using the convert to fraction button to help you out with this sort of stuff down here. Okay, so lots of going on. Make sure you show each step carefully, and hopefully this helps with this one.